TEDxBrussels. How are you? Excellent. My presentation today is making worlds. You've heard a lot about the singularity today. I can tell you I know a little bit about it because I'm co-chair of bioinformatics and biotechnology at something called the Singularity University. Yes, there is an actual university around this trends. It didn't exist yesterday, we just built it. We have 1 billion students. No. It is actually a really fascinating university, though, because it builds on what Eileen was telling you earlier. We're not trained to think exponentially. It really takes a new style of education and a whole new program to teach people about these technologies that are changing rapidly in our daily lives and affecting our lives. We've changed the world over the last 100 years. Hitching a ride on the International Space Station, we can literally see these changes. The cities are lit up at night. We can see the thin layer of the atmosphere. Thunderstorms in the distance coming up over here. We have literally built this world. We've transformed it. But where are we taking it? We just crossed the line. Most of our people now live in cities. We're not going back. And yet we can't all enjoy the same wealth and privileges that we have in the West. One sole tree here amongst humanity. We're seeing revolutions happen around the world because our demographics are changing. Power is still concentrated with the wealthy and the old. And yet we have young people moving up through the world that understand these technologies better, that need to use them, need to apply them. We're starting to lose our connection to the stuff that sustains us. Clean air, literally the land. We're over-consuming and we're polluting our waters. These are all major problems that we're running into the world today. Even space is not immune from this. The low Earth atmosphere is literally polluted with satellites. This is unsustainable, and we have to change it. We know this. Agent Smith in The Matrix kind of summed it up. Human beings are a disease, a cancer of this planet. You are a plague. How do we move forward? This is Danica Camacho, less than a month old, the face of the 7 billionth baby human being on this planet. Does she look like a cancer or a plague? Do you want to tell her that? Do you want to tell her that she's going to inherit a world that's not sustainable? I don't think so. We're in this incredible period, though, if you graph out the growth of humanity on this planet and kind of look forward to this 50 years into the future. We have this range of possibilities. No one knows where we're going to go. When talk about predicting the future, we don't even know how many people there will be on the planet in 2050. Some estimates just have it growing straight off the map. Others see this slowing down and we start to stabilize. And yet we really do not know. I call this zone the zone of the singularity. Because this is where we either get comfortable with our technologies and start to apply them in positive ways, or we do lose control. The big ones that really matter to me and the ones that kind of sit at the intersection of what I teach about at bioinformatics and biotechnology is obviously information technology. Our information technologies are transformative. They're changing the planet. These networks that we talk about, these mobile devices in Africa, the layers of information and data that we're collecting are fantastic, transformative. Another one is robots. This is how we actually go out and affect the world. Now, this can be as simple as automation and software, but it goes much deeper. You've seen robot cars today, and soon, many more robots will be interacting with us in the daily world. This is a robot called Petman at Boston Dynamics. It's getting pretty good at doing some of the things that we do. But my field is biotechnology, and it's beautiful because it combines both information technology and robots. These are my favorite organisms in the world. These are E. coli bacteria. They're in every one of your digestive systems. It's what's digesting your lunch right now. It's what literally feeds you. And we do this, we have a good working relationship with these bacteria. We carry them around the world. They sustain us. They're the ultimate exponential technology. They grow and divide, and literally one bacterium becomes hundreds of millions overnight, and they change the world. We understand these microorganisms. First of all, we didn't even know they existed until 400 years ago, when we turned the telescopes around and made them into microscopes. But we understand them through this code, this DNA, because we can't see them otherwise. We can't even grow most of them in the world. And DNA is the most powerful technology we have on the planet today, as far as I'm concerned. It's changing incredibly quickly. And we have the technology to read it using machines like this, which work on desktops. They're coming to your cell phones. It's incredibly cheap to sequence genomes. We have incredible new technologies for understanding it, most of them computer-based. But where it gets really fun is when you start to write it. And the key piece of technology that's come out in the last decade is a printer for DNA. Now, if you can type, you can be a genetic engineer. It literally comes back to you mailed in a tube. And from this, you can turn it into a biology. So we can go from bits to biology almost instantly. And this means biotechnology is changing fundamentally. Whatever you thought about the biotechnology industry, whatever you thought about life science, is radically transforming. Literally, it'll start to look more like an app store because it's so easy to start doing genetic engineering. These are some of the best genetic engineers in the world. They gathered 2 weeks ago at MIT in Boston. They represent teams of undergraduates and graduate students from almost 30 countries. And they are outperforming the biotech industry today. Some of their projects are breathtaking, and they're done on very small budgets. It's spilling out from academia into community labs like this. The first one opened in New York. Now there's one in San Francisco called BioCurious, and more will open around the world quickly. And they'll make things like viruses. My interest in this is to make viruses that give cancer cells colds. I think we can do that for free. I think we can give them away. Other people will make viruses to do other interesting things that are commercially useful, like make your hair grow or work as a vaccine. We're starting to make bacteria. This is state of the art, literally world-changing, gone full circle in evolution, bacteria to bacteria. And you'll start to see it come into the food chain. Micro Monsantos, farmers that actually engineer their own crops. Maybe pets that glow will start hacking our brains. I don't know where it'll stop. Humans? The human chromosome isn't that big, the human genome. Maybe it's time we have a project to write it. We already know how to boot it. Millions of people have been born with IVF technologies. One day, instead of saying there's an app for that, we may say there's an org for that. Or maybe a cyborg. It's coming fast. We have become world makers with these technologies, and it's really important now to think about what kind of a world we want to make in the future. And if you're worried about this, and there are many people that are, the layer that's coming into biosecurity and dealing with these challenges is everybody through these different types of communication channels. So I hope you get involved. I hope you think about biotechnology and what type of world you want for 2050 and beyond. Thank you.